Hi, kids. All right, so here's what we're doing today. Today we're going to do a short video talking about how do you charge something. Remember, when we're charging something, what are we doing? We're actually just moving electrons around. So when we have these different ways to charge something, friction, contact, induction, really what this is talking about is how do you move electrons around? Keep in mind, the elementary charge is 1.6 times 10 to the minus 19th coulombs. An electron has a charge of negative 1.6 times 10 to the minus 19th coulombs, which means your charge, because you're moving electrons around and you can only move whole electrons around, always has to be a multiple of this. Okay, so if you wanted to figure out how many electrons did you move around, well, if you have a 10 nanocoulomb charge, you would take 10 nanocoulombs and you divide by this number and you can figure out how many electrons got moved around. Of course, you'd have to change to coulombs, so it would be 10 times 10 to the minus ninth divided by this number and you can figure that out. Okay? But here's the three different ways to charge something, to move electrons around. The first way is you can charge something by friction. You guys are all familiar with this. This would be rubbing a balloon on your head. This would be shuffling your feet on the carpet. This would be clothes rubbing past each other in the dryer. Okay, charging by friction. In the wintertime, if you have cloth seats, getting in and out of your car, you a lot of times will develop a charge. Why? Charging by friction. Okay, when you do charge, when you rub two objects together, electrons rub off of one and onto the other. Well, how do you know which way the electrons go? Well, certain materials tend to give up the electrons more. Certain materials tend to grab the electrons more. This is called the Triboelectric Series. You don't have to know that, but this is how it happens. Anything higher up is going to tend to give up electrons. Anything lower down is going to tend to gain electrons. So if you look, rubber, like if you have a rubber balloon, and your hair, so if you rub a rubber balloon on your hair, that balloon is going to gain electrons, your hair would lose electrons. Hence, your hair would get a positive charge, and the balloon would get a negative charge. Okay? All right, charging by friction. Okay? Charging by contact. Charging by contact is when two objects touch and literally electrons transfer. If you have ever seen the little zap, you hear the little zap when you go and you touch a doorknob, that is because electrons are transferring over. That is an example of charging by contact. So anytime you see those little sparks, that's charging by contact. If you see a giant spark like lightning, that's charging by contact. Okay, that electrons are literally transferring. And this is where I want to make sure you understand. Like with lightning, the cloud isn't actually touching the ground, but that's still considered contact because you're transferring electrons. If you charge your hand up really well, or yourself up really well, and so you get charge all over you, you could just bring your hand close to a doorknob without actually touching it, and the charge will transfer. Okay, contact. Okay, even though it's not actually touching. And I'll give you an example of something where it actually is touching and it's not contact. Okay, and then I think these two are pretty straightforward: friction, contact, and then induction. Induction is where a charged object, you already have a charged object, and it's brought close to a different object, and that other object develops a charge. Okay, this is polarization. There's two types of induction. One is polarization, one is grounding. So this is the one I'm going to focus on right now because I think these two are pretty self-explanatory, at least I hope they are. So let's say that we'll do one kind of with everything. So here you are, here's your hair, and here is a neutral balloon. Okay? So one way to draw neutral is just to say, hey, everything's positive and negative. One way to draw neutral is just to say it has no charge, so I'm not going to draw anything. Well, when I take the balloon and I rub it on your hair, so we take the balloon and we're going to get much happier because it's a very good time to rub a balloon on your head. So when I do this, okay, literally electrons are transferring over. Okay? So this is electrons transferring from the person's hair to the balloon. And then when you are done, your hair is going to be here where you rubbed it. There is going to be a positive charge, okay? And the balloon will have a negative charge on it, okay? Couple things just to keep in mind. The net overall charge has to stay 0. So if this develops a positive 3 something charge, this would have to develop a negative 3 something charge. But that would be charging by friction. Okay? Charging by contact, I would take my charged balloon and touch something. Now, if I want to do charging by contact, I would have to touch something that is metal. Okay? If I don't touch something that is metal, then that would not be charging by contact because you have to transfer the charge. So let's talk about that. If you take, okay, and my negative balloon, and I put it on a wall, okay, what's going to happen, there's my negative balloon, what's going to happen is right here, hopefully you can see how I've separated the charge. Okay, this separation is called polarized. I polarized the charge right there. Now, away from the balloon, it's just all going to be, it's all positives and negatives throughout. So like this part is neutral, this part is neutral, but this part I have polarized. This idea of induction with polarization is why a neutral object, in this case the wall, will be attracted to a charged object, okay, because of that polarization. Now, if your object here, so like if I brought my negative balloon close to a can, for example, so let's say I have an aluminum can. Okay, do you see how my wall is an insulator, so the charge doesn't move very much? But if I had, it would probably look something like this, because it doesn't move very much, okay? Whereas if I have this, or if I have my negative balloon here, then the charge in this can is going to get separated a lot. Why? Because that can is a conductor. Where if this was a wooden ruler, and I think you guys did this, it would look more like this. Okay, plus minus, because this is an insulator, so the charge is not going to move very much. Induction with polarization. That's induction with polarization. Okay? All right. So now let's do induction with grounding. Let's say I have this situation. So my can is attracting my balloon, and then I go and I decide I am going to touch the can. There's my giant Homer Simpson hand. Okay? Now, these negatives are moving over here. Why? To get away from the negatives on the balloon. Like charges repel each other. Well, if I touch this, and in fact, I could touch it anywhere. I could touch it on this side, up top, or anywhere. Remember, this is a metal, so the charges move freely. And people are also really good conductors, so again, charges can move freely. Well, these electrons now, they're trying to get away from the negative charge here, so these negative charges will literally move onto your hand. And when you touch that, you'll feel a little zap. Why? Because the charge is transferring. Well, then if you take your hand away, now what's going to happen, your balloon is there, but now your can is going to have a positive charge on it. And then if you take the balloon away, now that positive charge is going to spread out because it's a conductor and it's going to sit on the outside. This would be an example of induction with grounding. Why grounding? Because I have taken this charge and brought it to the ground. Like, it's come to me, but eventually it's going to get to the ground. Okay, hence that's why it's called induction with grounding. But remember, induction with grounding only happens if you have polarization first, and then while the polarization is going on, you then touch it or you bring something to allow the charge to get even further away and go away to the ground, and then you take that charge away. Okay? Hopefully that makes sense. Bye, kids.